Every single high-rise fire above the 10th floor in America, Europe, and Canada is being fought from the outside because the tallest ladder platform most Western fire departments own cannot reach beyond roughly 100 feet. You heard that right, 100 feet. That is about the height of a 10-story building, and everything above it is on its own. And that is just the beginning, because while the West has been living with that limitation for decades, China just made it irrelevant entirely. If that floors you, hit a quick like and subscribe so you don't miss the next one. By the end of this video, you are going to understand exactly how China built an entire generation of firefighting technology that the West does not have, cannot quickly replicate, and may already be too late to catch. Here is where the story starts, with the single most inconvenient fact in modern urban firefighting: the wall that physics built. Picture a garden hose trying to water a tree from across a football field. The water leaves with force. But gravity, distance, and the simple physics of pressure loss mean that by the time it reaches the canopy, it is little more than a mist. That is essentially what happens when a Western fire department points a hose stream at a high-rise fire above the 10th floor. The water gets there, but not with enough force, not with enough volume, and not close enough to the seat of the fire to do what needs doing. Now understand that this is not a funding problem. It is not a training problem. It is not a problem that a new administration or a bigger municipal budget fixes. It is a physics problem. And physics does not negotiate. The tallest aerial ladder platform in regular service across most Western fire departments tops out at around 100 feet. That is the height of a 10-story building. In a city like New York, London, or Toronto, that means every floor above the 10th is beyond the mechanical reach of the most advanced ground-based aerial equipment those departments own. Not slightly beyond reach, completely beyond reach. Here is the part that most people never think about. The solution Western departments developed for this was not a better ladder. It was a doctrine. The doctrine is called defend in place, which means when a high-rise fire breaks out above the reach of aerial equipment, the strategy shifts from aggressive exterior attack to interior suppression via standpipe systems built into the building itself. Firefighters go in, they climb. They connect to internal water supply infrastructure and fight the fire from inside the building. The ladder outside is not the primary weapon. It never was. For high-rise fires, the building is supposed to fight itself, with crews inside directing the effort. That doctrine works. It has saved lives. It was built on decades of hard experience and genuine engineering discipline, and it deserves that acknowledgement. But it carries an assumption so large that most people standing next to it cannot see it. The assumption is that the building's internal systems are intact, that the standpipes are pressurized, that the stairwells are clear, that the fire has not compromised the very infrastructure the firefighters are depending on to do their job. Now here is the brutal catch. In a fast-moving high-rise fire, the kind generated by modern synthetic furnishings that burn 6 times faster than wood-framed interiors from 40 years ago, that assumption fails faster than any doctrine can. Adapt to it. Interior crews get cut off. Standpipe connections get compromised. Evacuation routes collapse. And the firefighters outside, with their 100-foot ladders, watch floors 20, 30, 40 burn, with nothing in their toolkit that can touch it. Western fire engineering did not ignore this. Researchers flagged it. Equipment manufacturers pitched solutions. Taller platforms were tested. But the economics of a piece of aerial apparatus that costs over $1 million requires a specialized operator and physically cannot navigate the narrow street grids of most older Western cities, kept the ceiling exactly where physics put it, 100 feet, unmoved. The West looked at that ceiling and learned to work around it. China looked at the same ceiling and decided to go straight through it. But the way China got there is not the story most people tell. The real story starts not with a drone, but with a skyline that made everything the West built effectively useless overnight. Why China had no choice. Think about a city the size of Los Angeles. Now imagine that city did not grow outward over 100 years. Imagine it grew upward in 20. That is not a hypothetical. That is Shenzhen. That is Chongqing. That is what happened to dozens of Chinese cities simultaneously, at a pace that had no modern precedent and no historical playbook to follow. China currently has more skyscrapers above 650 feet than the rest of the world combined. You heard that right. More than the United States, more than Europe, more than the entire Middle East, all added together, and it is not close. While Western cities were still debating zoning laws and height restrictions, China was topping out residential towers at 40, 50, 60 floors and filling them with families. Now here is what most people never consider. A skyscraper is not just an engineering challenge when it is being built. It is an emergency response challenge every single day it is occupied. Every person living on the 45th floor of a residential tower in Chongqing is depending on a fire department that can physically reach them if something goes wrong. And the taller the building, the more brutally that dependency exposes the limits of conventional equipment. Chinese fire departments saw this coming. Not in the abstract policy document way that bureaucracies see things coming. In the urgent, operational, people are going to die way. Because they were already watching their cities grow faster than any retraining program, any equipment procurement cycle, or any international technology transfer could keep pace with, the buildings were going up. The equipment was staying the same, and the gap between the two was not a budget line item, it was a body count waiting to happen. Here is the detail that puts everything into perspective. China was not looking at this problem from a position of technological ambition. It was looking at it from a position of operational emergency. The drone programs that followed were not research projects handed to aerospace engineers with open budgets and 5-year timelines. They were crisis responses handed to engineering teams with a very specific brief: solve the problem that our cities have already created and solve it before the next major fire makes it impossible to ignore. That distinction matters enormously because it means every single drone in China's firefighting portfolio was built around a real operational requirement, not a trade show, not a government demonstration. A documented gap between what Chinese fire departments needed to do and what their existing equipment would let them do. That gap had a number attached to it. It had floors attached to it. It had addresses. And the engineers delivered. Not one system, not a prototype that never left the testing range. An entire portfolio of aerial firefighting platforms, each solving a different layer of the same problem, each more capable than anything the West had thought to build. The first one alone is enough to stop you mid-sentence. The first wave, speed and reach. Imagine you are standing outside a burning building. The fire is on the 20th floor. You can see it from the street orange light pushing through the windows, smoke banking up the glass face of the tower. The fire truck is 3 minutes away. The aerial platform is further, and every second that passes, the fire doubles in the area it controls. Now imagine something else appears, not from the street, from above. It was airborne before the truck left the station. That is not a hypothetical scenario in China anymore. That is the operational reality the General Aviation Equipment, aerial scooper drone, was built to create. Here is what makes this system genuinely different from anything in a Western fire department's inventory. Speed is the first thing. This drone reaches 200 meters altitude in just 30 seconds. 200 meters is roughly the height of a 65-story building, taller than anything a Western aerial ladder platform can touch, reached in half a minute from the moment it launches. While a fire truck is still navigating the first set of traffic lights, this drone is already at the fire floor. But speed without payload is just a fast camera. Here is where it gets serious. On a single pass, the General Aviation Equipment drone covers 200 square meters with dry powder suppressant. 200 square meters is roughly the floor area of a typical 2-bedroom apartment. One pass, one drone, one floor of fire coverage delivered before the first ground crew has pulled a hose line. Now here is the part that most people overlook when they first hear those numbers. The drone is not replacing the ground crew. It is buying the ground crew, the one thing no piece of equipment has ever been able to give them at a high-rise fire time. Every second of fire growth that gets interrupted at altitude is a second that interior crews do not spend fighting a larger, hotter, more structurally compromised fire when they finally get inside. The drone is not the whole answer. It is the answer to the first 5 minutes, which fire behavior science consistently identifies as the most consequential 5 minutes of any structural fire. Here is what makes this even harder to dismiss. The drone arrives at the fire scene faster than a fire truck can reach the building in a dense urban environment. Chinese cities with their concentrated high-rise clusters, their narrow approach corridors, their sheer population density are exactly the environment where ground response times stretch. The drone does not get stuck in traffic. It does not need a clear street. It does not need a staging area. It needs airspace. And in the first minutes of a high-rise fire, that airspace is available. Western fire departments have drones too. Reconnaissance drones, camera platforms, systems that circle a fire and send back thermal imaging so incident commanders can make better decisions. Those are valuable. Nobody is dismissing them. But there is a canyon of difference between a drone that watches a fire and a drone that fights one. And China has spent the last several years building exclusively on the fighting side of that canyon. But the General Aviation Equipment System is the entry point of this portfolio. What China built next was heavier, smarter, and capable of staying in the fight 60 times longer. The heavy lifters. Think about a toolbox. The first tool you reach for is usually the fastest one, the one that gets you into the problem quickly, but fast tools are rarely the ones that finish the job. For that, you need something heavier, something built for sustained work under pressure. Something that does not quit after one pass and need to land. That is exactly the engineering logic behind the next tier of China's firefighting drone portfolio. And it starts with a machine that looks less like a drone and more like a small industrial aircraft that forgot it needed a runway. The Didoc Making's Z50 is a heavy unmanned aerial vehicle built from aviation-grade aluminum alloy, 6 rotors, a 17.5 horsepower engine, and a suppressant delivery capacity of 50 liters per pass, roughly the volume of a standard kitchen trash can, released with precision at altitude in a single run. It is engineered to withstand level 5 wind gusts, which puts it in conditions that would ground most commercial drones and make manned helicopter operations genuinely dangerous. And it carries fire-extinguishing bombs designed for precision vertical targeting, meaning it does not carpet spray a floor and hope. It identifies the fire source and drops on it directly. But here is the detail that separates the Z50 from everything in the first wave. 60 minutes. That is, its continuous airborne endurance on a single charge. 60 uninterrupted minutes above a burning skyscraper, delivering suppressant, repositioning, and delivering again. In fire behavior terms, 60 minutes is not a drone deployment. It is an aerial suppression campaign. Now, here is what makes this even more significant when you pair it with the second system in this tier. The XCMG Group platform does not arrive alone. It deploys from a specialized truck carrying 2 fire rescue drones and a dedicated reconnaissance drone operating simultaneously. Think of it less like a single weapon and more like a coordinated strike package that happens to travel on 4 wheels. The reconnaissance drone goes first. It maps the fire zone in real time using thermal imaging, identifies structural weaknesses before a single crew member steps inside, and charts safe evacuation routes for ground personnel working around the base of the building. That information feeds directly to the incident commander. And according to XCMG's own deployment data, it reduces initial response decision time by up to 30%. 30% faster decisions at the moment, when every second of delay has a direct consequence on the floor plan above. Here is what most people get wrong about that number. They hear 30% faster and think efficiency. What it actually means is fewer crews sent into structurally compromised spaces without knowing what they are walking into. Fewer firefighters trapped on floors that thermal imaging would have flagged as unsafe before boots ever touched the stairwell. The reconnaissance drone is not a convenience feature. It is a casualty reduction system. The XCMG platform has already been deployed in high-rise rescue drills in Chongqing, a city of over 30 million people, larger than the entire population of Australia. Stacked into towers along river valleys, where conventional aerial access is some of the most challenging urban terrain on Earth. It has also been proven effective against forest fire reignition in terrain so steep and so remote that no ground crew and no conventional aircraft could reach the seat of the fire before it rebuilt itself. If this surprised you, the next part is going to be even harder to believe. Hit subscribe so you're there when we cover it. 2 systems in this tier, both extraordinary. But neither one of them does the thing that makes the next chapter the one that genuinely stops people mid-conversation when they first hear it. Because the next drone does not wait for a window to be open. It makes its own. The glass breaker. Here is something that almost never gets discussed in conversations about high-rise firefighting. The windows are the problem, not the fire, not the height, the windows. Modern skyscrapers are not built with openable windows. They are sealed units. Tempered glass, engineered to flex under wind load, resist thermal expansion, and hold the building's internal climate envelope intact. From a structural standpoint, that glass is doing exactly what it was designed to do. From a firefighting standpoint, it is a wall between a suppressant delivery system and the fire it needs to reach. And in a sealed high-rise, that wall exists on every single floor, around every single face of the building, from the ground all the way to the roof. Western aerial platforms deal with this the same way they deal with the height problem they largely do not. Interior crews breach windows manually from inside. Exterior streams are directed at glass and hope the pressure is sufficient to break through. In a fast-moving fire on a high floor, neither option is fast enough, and neither option is available from the outside at altitude. China's answer to this is the Jiangsu Digital Eagle SKX F07, and the way it solves the window problem is the detail that engineers do not particularly want to admit their own systems missed. The SKX F07 carries 4 fire-extinguishing bombs per flight. Each one is individually engineered with a hardened impact tip capable of breaking 12mm tempered glass on contact. 12mm tempered glass is the standard specification for curtain wall glazing on commercial and residential high-rise construction across most of the world. This drone was not built to a general specification. It was built to the exact specification of the obstacle standing between a suppressant and a fire. Now here is the part that stops people. Each bomb, once it breaches the glass, releases dry powder suppressant across 36 cubic meters of interior space. 36 cubic meters is roughly the volume of a standard shipping container. 1 bomb, 1 window. 1 container-sized cloud of suppressant delivered directly into the fire compartment from outside the building, at altitude, without a single crew member needing to be inside. 4 bombs per flight, 4 windows. 4 compartments reached and treated in a single drone deployment that launched before the first ladder truck cleared the station parking lot. And here is the detail that makes this system genuinely extraordinary, rather than just impressive. It does all of this without causing harm to building occupants. The dry powder dispersal pattern and the delivery velocity are calibrated so that the bomb breaches the glass and suppresses the fire compartment without creating a lethal projectile event inside the room. The drone is making a forced entry into a burning building, and it is doing it more safely than most manual breaching techniques available to interior crews. Here is what makes this even harder to process. The SKX F07 is not the most capable system in China's portfolio. It is not even close. It sits in the middle of a lineup that ends with something so far beyond a firefighting drone that the first time most people hear about it, they assume it is fictional. It is not fictional. It flew, it fought a live fire, and it started life as something you could book a seat on. The passenger jet that became a weapon. EHang builds passenger air taxis, actual air taxis, the kind you book a seat on, climb inside, and ride to the other side of a city without a pilot. That is the product. That is the commercial identity of the company. And at some point, an engineer at EHang looked at that platform and asked a question that nobody in the West had thought to ask. What happens if we arm it? What came out of that question is the most extraordinary entry in China's entire firefighting portfolio. EHang stripped the passenger cabin, replaced it with a 150-liter foam tank roughly the volume of a standard bathtub, and added a high-pressure water cannon, a 6-charge bomb launcher with hardened glass-penetrating tips, and a laser target designator for precision aiming. Then they made it autonomous. The system flies itself from fire station to fire site. No pilot in the aircraft. No remote operator guiding it through city airspace. It navigates, it climbs, it positions, and then a ground operator assumes control for the extinguishing sequence. EHang claims it can engage fires in skyscrapers up to 600 meters tall. 600 meters is roughly twice the height of the Empire State Building, within a 5-kilometer operational radius. And they did not just claim it. They demonstrated it publicly, flying the system to the penultimate floor of a 10-story building in Yunfu and extinguishing a live fire on camera. That is not a trade show. That is a proof of concept with an address attached to it, and it makes everything the West currently operates look like it belongs in a museum. But here's the thing. As jaw-dropping as every system in this portfolio is, the drones themselves are only half the story. The half that actually keeps Western defense analysts up at night is what China plans to do with them next. The gap the West can't close in time. Here is what the West is doing right now. American fire departments are navigating FAA regulations around autonomous drone flights beyond visual line of sight. Skydio, the most advanced American drone manufacturer in this space, is pitching reconnaissance platforms for fire monitoring, watching fires, not fighting them. The most capable aerial firefighting platform widely deployed across Western fire departments is still a manned helicopter with a water bucket. That technology predates the iPhone by 4 decades. You heard that right. 4 decades. Now here is the part that nobody in this conversation wants to say out loud. China is not keeping this technology inside China. It is positioning every system in this portfolio for export to every rapidly urbanizing nation whose skylines are growing faster than its fire departments can follow. Southeast Asia, Africa, South America. Cities adding high-rise towers by the hundreds, with fire departments still operating on Western equipment paradigms that cannot reach above the 10th floor. The countries that adopt Chinese firefighting drone infrastructure will build the same operational dependency that American police departments built on DJI drones embedded so deeply into emergency workflows that no ban, no tariff, and no domestic alternative arrives in time to matter. And every skyscraper fire fought with a Chinese drone feeds data back into the AI training pipeline that makes the next generation more capable than the one before it. The gap does not stay the same size. It grows. If this changed how you think about the global technology race, hit that like button and subscribe so you never miss what comes next. Now I want to hear from you in the comments. Is China's firefighting drone program a genuine public safety breakthrough, or is it a Trojan horse that trades lives saved today for strategic dependency tomorrow? Drop your answer below.